Multiplying and dividing rational functions. So the rest of this unit, we're going to be looking at rational functions. We already finished with root functions, right? We looked at square roots, cube roots, other kinds of roots a little bit. So now we're going to be looking at rational. When you hear the word rational, I'm hoping by now, since you've seen it for many years in a row, that your brain says what?
Square root.
That's radical.
Oh, yeah, excuse me.
Rational means, well, what do these things all have?
X.
A top and a bottom?
Fraction.
Fractions. They mean fractions. So we're going to be looking at fractional functions now. We looked at the picture of the most basic rational function yesterday, 1 over x, right? It was in quadrants, what?
2 and 2.
It was in quadrant 1, right? There was a piece up here, and there was a piece down here. So that's kind of what the graphs look like if you look at the most basic graph. Eventually, we're going to look at some more complex graphs. But before we get to graphs, we better be able to work with these things in terms of adding and subtracting and stuff. So today, we're going to multiply and divide them. Okay? So let's see, how can we simplify? So these problems, the directions say something like, simplify the rational expression or the function or whatever. So simplify this guy. What can I do? Well, 10 over 6 becomes 5/3. But let me write this out the long way in case you forgot how to do something like this. I hope not. But if you write this out the long way, then you can say 10 becomes something like 2 times 5, right? And x to the 8th is x, 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 x. So I'm guessing you don't want to do this anymore after this problem. I'm just showing you my head thought process. My thought process, yeah. And 6 we could write as 2 times 3, yes? Okay, 1, 2, 3, 4, 5, 6. All right, so how do I simplify that now?
Doesn't you
Cross
cancel
out.
out 6?
I cross out stuff, good. 2's and 6 of the x's. Man, oh God. I think I did it right. All right, so what's left? Now you can write it like that. Somebody asked me this morning, should I write it like that, Mr. McGee, or should I write it as 5/3 x squared? I don't care which way you write it, it's the same thing. If you don't know that this is this, that's a little bit concerning. Though. You should be able to flexibly go between these two things when necessary. Okay, they're both right answers. All right? So there's that one. So now let me tell you, what can I do over here to simplify? Caution.
Can you cancel out the x squared?
Oh, thank you so much, Mr. Colbert. It's such a great opportunity you provided me with. So I love having you in my class. So Kyle's looking at this and he's going like that, right? So he's saying like the answer would be, and then you could like cancel these x's too, right? Maybe it'd be like 1/2, something like that.
Well, they're not the same.
Let's see if that makes sense with like some simple numbers. Okay, let's do just some numbers, no variables. Just see if that makes sense. So I'm thinking that if that's true, then you could do something like this. Couldn't you go like 2 plus 1 over 2 plus 2? How would that simplify?
1 over 2's.
And if that cancels out, it cancels out to what?
No.
Does it cancel out and go to 0 or 2 or 1 or what? See, why did these cancel back here the whole time on this previous problem? We were pretty confident about that one, right? Like, why did those cancel out? Why do you get to cross out all those things with the red there? Because what is 2 over 2 really? 1. What is x over x really? They're all multiplied by 1. Okay? So I'm guessing you guys were thinking, well, then probably this cancels to 1, right? So you get like what? 1 plus 1/2? 1.5? I'm not so sure, because I think that, like, don't you supposed to do this as, like, do the top first? There's hidden parentheses here from PEMDAS. Yeah? Parentheses, then exponents, then multiply, and then add and stuff like that. So I think this is really 3 over 4. Don't you guys? Now, if you don't believe me and you're watching the video or something right now, like I asked my class to earlier, you guys too, grab your calculator and tell me which one your calculator says is the right answer. Is it 1.5 or is it 3/4? I don't trust my calculator a whole lot. But I think it can handle something like this. Make sure you, of course, put parentheses on the top and bottom or use alpha y equals. Yeah, try it. See which one. Do you get 1.5 or do you get 3/4? Hurry. You got 3/4, Damon? You guys get 3/4?
You're dummy. I did it. Look. You see
I got 75.
If it's longer,
You got 0.7.
Okay, so it sounds like most people are getting the 3/4. All right? So, flip to the front of your notebook right now. I think we had a section by our library of functions, hopefully, that should say algebraic mistakes of infamy. This is one of them. So I don't know if we were on the third or fourth one. By the way, in future classes after this one, do I continue adding mistakes of infamy? There's only 4. Those are the only 4 big mistakes that you can make pretty much in Algebra 1, 2, Calculus 1, 2, 3, up through huge amounts of math. There's only these 4 things that you've got to really avoid doing. One of them is canceling what, like we just were tempted to right now. So you cannot cancel x squared over x squared like that. So in the algebraic mistakes of infamy part of your notebook, let's try to write this in words. What are we not supposed to do here? Any ideas? You could write this as an example, right? So for an example, you could use this problem. I'm going to write it down for any of those interested, though. So I'm going to say, I think this is our third or fourth one, guys? Is there a second one? Okay, we'll call it the second one. So I thought it was the third one, but whatever. I think it's that when you have the same expression, same thing, however you want to write it, on the top and bottom of a fraction, you can only cancel if what? If it's 1, well, that's 1. The problem is, though, here we were doing what with each of the pieces? Multiplying. Here, there's pluses and minuses in the way. So you can only cancel if you have multiplication. Or division, it will work with too. But I'm going to write it as multiplication. Pluses or minuses separating terms prevent this. If you've got plus and minus separating things, you cannot cancel. And the reason is not complex. It's because PEMDAS says you can't cancel. That's not 1. It could be all kinds of things depending on what x is. Okay? So that's my shortcut way to do this. So you could write this down as an example of what you can't do. So, I don't know, write that as an example right there. X squared plus x minus 2. This is not equal to 1 plus 1/2. Negative over negative is positive. That is definitely not something you can ever do in math. And I'm making a big deal out of this because this does not just apply to fractions. This applies to square roots. If there's a plus or minus inside square roots, you can't cancel. It applies to cube roots. It applies to logarithms. It applies to exponentials. It applies to parabolas. It applies to pretty much every function you'll ever run into. This idea of separators being pluses and minuses and stopping cancellation. Okay? So let's learn how to do this the right way then. So how do we do this? I'm hoping, and this morning they seemed a little bit asleep. I'm a little asleep today too. I'm trying not to let on to you guys. My calculus lesson did perk me up a little because we did some cool stuff. But you should look at that on top and bottom and be like, I think I've seen this before. I'm going to factor it. I think these ones both factor. 2, not a lot of choices. It's 2 and 1 or nothing. 3, not a lot of choices. It's 3 and 1 or nothing. What's my combination down on the bottom?
Positive 3 and
Yep. What's my combination up on top? There we go. Check that if you like of the factorization process. But now I got rid of the plus and minus separators. So now, what can I do?
Cancel.
Cancel out.
Because now you've got multiplication between the things. That's where cancellation is allowed, because that's just 1. And multiplying by 1 does not change what you are. So this cancels down to x plus 2 over x plus 3. So let's do the same thing on this guy. Yeah, I think that's about as simple as you can see. You were tempted again, weren't you, Kyle? Kyle's tempted. He's like, oh, x over x cancel. Nope. Okay. What about up here? Is that bottom factor?
No.
I think so.
Yeah, it does.
4 and 2.
Yeah, no way, no.
Which one's which? Like that. 4 times negative 2 is negative 8, yes. 4 minus 2 is 2.
Yeah.
No.
No, because it's a negative 2.
Negative 8,
Okay.
negative 2. There we go. Now the top, remember, you've got a couple factorization procedures. You can't continue in mathematics without knowing how to factor. So that's the standard regular one. I call it standard trinomial. On top, you can't do standard trinomial, but you can do another one. Is it a difference of squares? So close. Good. Difference, yes, but that's not a square, so no, it's not difference of squares. They share something. What is it? This is a what they share factor problem. If I pull out x, 4 is left, x is left. Now you guys look at that and tell me, can you cancel?
I'll say
You're the one who decided.
It's looking good, kind of good. It's close. You can almost cancel what? These. They're so close, but here the x is negative, here it's positive.
Is that you? Okay.
And vice versa with the 4. Factor out a negative, exactly. So Michael's saying, hey, take one more step. Instead of pulling out a positive x, pull out a negative x, which will make this x become what? Positive, and it'll make the 4 become negative. Now it's all ready to cancel because it's multiplication. So we've got a little bit simpler rational expression left. Now, your problems are going to ask you to do one more thing, which is kind of important. They're going to ask you to look at your answer and ask yourself, are there any things you can't plug in? Is there anything you can plug in which will break the function? These last 2 problems definitely have something that will break them, at least one thing. So let's focus on just the answers at the end first. What's going to break this function? You can plug something in that will break it, and your calculator won't do it. It'll say error, divide by 0 or something. Negative 3, so that's what they're asking for. They're going to say, where is the function undefined? And you're going to tell them, you know what, if I plug in negative 3, it's dividing by 0, and I'm out of luck. Your calculator, you try to do it, it's not going to do it. It's going to say, nope. Okay? And there's actually another thing if you plug it into the original function that'll break it too. What's one more thing that will break this if you go back here? Because there's some kind of sneaky simplifying. When you cancel this out, this graph and this graph are exactly the same. We'll see that next week. Except for one thing. One little bit sneaky thing on the graph. There's one other thing which will break this too.
Would the making the x negative break it?
I'm thinking a specific thing you can plug in, Kyle, like 7 or 8 or 10,000 or negative 3 or 2 or something like that. If you put 1 right here, what do you get? If you put 1 right here, what do you get? What's 0 over 0? It's not 0. It's kind of undefined, but sometimes it's not, too. It's something strange, which is going to break something in your graph.
Yeah, it says you can't do it.
Yeah, see, Sean's already trying this. You guys see, you've got calculators out? You should try this, too. So if you're watching the video, I'd recommend pausing it right now and plugging these into your calculator and seeing if it actually breaks it. We're going to do that. So I argue that if you put 1 in, it's also going to break that. Let's try it. Okay, so a couple more examples. These both have just multiply and divide in them as well, right? They might look slightly different, but they're not. If you have like a half times 2/3, how do you multiply fractions like that? Don't you go across the top, across the bottom? So I can make this into one big fraction by going like this. Now, Michael, I heard you say x squared, so Michael's trying to expand that out. I think I'm going to leave it as factors because I want to see if I can cancel stuff, you know? So you can do the same thing with these two. I'm going to save myself some work, though. That one on the left, I think you can factor it. These are pretty basic. You can't do much with them. That one shares something. What's left? And this, I'm hoping by this point in the year, jumps out at you and says, I am something, I am something. It's a difference of squares. So you can factor it by going minus plus, first thing squared. What's the second thing being squared?
3.
Yeah. All right. So now ask yourself, can anything cancel out? Lily, help me. What cancels?
Would the -3 cancel out?
What do you mean the
X
negative
minus
3? You mean this?
Yes.
You mean the quantity x minus 3? I gotcha. Okay. What else?
And then the x by
Anything else?
no.
I think that's it. So what's left? 0 up on top, right?
So would
4 times
it
x
just
plus
be
3.
4 times x plus 3?
Yeah, but if you have 0 over stuff, it's still 0. That's like nothing.
So
it's like saying 0 divided by
Yeah, right. This is nothing. It's not 0. What do these cancel out to? Why are we allowed to cancel again? Go back.
Can you distribute the 4?
It's because that stuff is 1. And yeah, you could totally distribute the 4 if you wanted to, but see, this is factored. And when you see the factored form, it's easier to pick out things like, where's this undefined? At -3. Put -3 in, it's broken. That's going to show up on the graph next week when we look at the graphs. It's going to be something on the graph.
is that
Okay.
function broken or
Well, that's the function, but I'm just saying if you plug in -3, it's undefined there. So there's going to be something funky if you graph this function. If you put it in like y1 in your calculator, there's going to be something weird at -3, and there's 2 other places you can have something weird. -5 and +3. You're also going to have something weird. Okay? Let's try this one. How about division? Do you guys remember how to divide fractions?
Cross multiply.
Yeah, cross multiply is a terrible thing that middle school people do. I think you say change that to dot, copy, dot, flip. Yeah, so that's what we're going to be doing here. So let's do it. So we're going to go copy, dot, flip. You could skip this step totally and just mash it all together at the beginning. That's what I would do. It's up to you though. There's different ways through this problem for sure. And then you can start canceling stuff out because you have multiplication, right? And it goes to 1. So what cancels out here, guys?
The y2 y squared.
Y squared, the 8. I heard both those. Yep, they're all gone. What else?
That's it.
Some of the x's go away, don't they?
Yeah, 2 of them.
2 of them. We've got 5 on top, 2x squared's left on top, everything else is gone. Those are gone with
15's on the
those.
bottom.
So 15, oh, and 15 is 5 times 3, so you can write it like that, or you can write it like that. Both forms of the right answer. Okay? Let's look at one more example, and then there's plenty more posted on Moodle. So the guy who runs our textbook, his examples are also good. Use them if you need them, and you might this weekend. So here's a more challenging one. I gave this as a money challenge this morning. I'm sorry I'm out of money, so I will give you guys a money challenge of very similar nature. on Monday to warm up. I think I've told you everything you need to know to be able to do that. Give it a shot. I'll give you 5 minutes. So the winner will earn honor today. So on the board we have another example of a rational combination of two rational functions. So this time we're dividing. So let's have a look. What you want to do, just like last time, is you want to first do the copy dot flip procedure. We're dividing one rational expression by another. When you divide one fraction by another fraction, that means you've always got to flip the second one. So first I'm going to do that. You know what, and I'm also going to do everything in one step on this because I want to be efficient and not write down everything multiple times. So I'm going to flip this guy. And while I'm flipping that guy, I'm going to factor each piece as well. So you can see that this first two, I think you can factor it a couple different ways. In one of my classes today, somebody looked at it and said, hey, that's a difference of squares right now. You might not see that, but you might say, hey, they share an x squared. I think either way is completely appropriate. So I'm going to say they share an x squared. Let's factor it out. What's left? Another x squared and the 9. Turn this all into one fraction. So then we agreed we're going to flip this one. So this guy, you should recognize this guy by now. This guy's a difference of squares for sure. So it's x minus 4 and x plus 4. Notice I wrote it on top. All right, so then we've got this one over here. This is a straight up trinomial. 3 and 1 are our only choices if it does factor, which it does because I can put a negative and a negative. That makes a positive 3 and they add up to negative 4. So now remember this guy I'm going to factor underneath now. So this guy, what do they do here? Oh, they share an x squared between all three terms. So if I pull that out, there's another x squared left. 2x minus 8. So I'm going to have an x squared down here. And then I think this guy factors as well, just like this one. 8, I think we can go 4 and 2. Plus 4 minus 2, that's negative 8. That added up is positive 2. So now let's look at this and see all the pieces we can cancel. So it's all multiplication, so I don't have to worry about making an algebraic mistake of infamy. Luckily, it's all multiplied, so I can cancel any repeated quantities like this one, the x squared. I don't see anything else I can cancel right away, but oh, this is difference of squares, so let's fix that. That's x minus 3x plus 3. And I think that'll let me cancel this piece. So what's left? On top we have an x plus 3 and an x minus 4 quantity. And on bottom we have an x minus 1 and an x minus 2 quantity. So that guy's done. Where would this guy be undefined if we were asked? Well, I think you can't plug in 1. That'll make the bottom 0 and break it. 2 will make the bottom 0 and break it. And also 0, negative 4, and 3. So there's 5 strange things that are going to happen on this function. So we'll look at the graph and see where those come up next week. Okay guys, so the last thing that's in here, besides simplifying stuff, there's some basic equations. We're going to have a whole section on just how to solve equations like this, but this is a nice introduction. Don't make these harder than they are. There's multiple ways to do them. There's probably at least one really easy way to do them. So let's look at that first one. Solve for x. Something in it should just jump out at you as like, I've seen that before.
X squared minus 45.
Yes. What's Sean talking about? How come he's looking at the top and he's like, I've seen that before? It's a difference of squares. You can factor it. How? I heard it. Go plus 5 and minus 5.
Oh, hey.
Now, on this particular problem, because it's cooked up to be basic and easy, what happens? This is like a whole chunk. It's multiplied right there, right? There's the multiplication, so we are allowed to cancel. So you can cancel it. What's left?
X plus 5.
And we can all do that. Subtract 5. You get 9.
That was quite simple.
Let's try to apply the same approach on this one.
Pardon this interruption. Seniors, final reminder, your letter of interest
Yes,
and
we
resume
know.
for the Rio Martinez Scholarship needs to be in today to Student Services. Also, junior girls, the application to Girls State, the application with the essay questions and a resume also needs to be turned in today to Student Services. Thank you.
Okay, so I heard a couple people during that much fun announcement who had factored it. I think it factors like that, right? -2 times 5, -10, 5 minus 2 is 3, yes. It's definitely factorable, which is really nice because in this case, that cancels out, and we get x plus 5 equals 7. So the answer is 2. Now in one of these problems, we have made not a mistake necessarily, but you've got to think a little bit, because remember how when we did radical equations, there were these things that popped up sometimes that weren't answers. What were those called? Extraneous solutions. Sometimes these have them too. Most equations that are beyond really basic algebra have that possibility. One of these answers is extraneous. Which one?
It's the x equals 2.
Sean's saying the 2. Why is the 2?
If you plug it in, it's 0.
If you plug it in up here, I mean the top comes out as whatever. What's the bottom going to come out as?
0.
That's a problem. That's broken on the left-hand side. That's not going to work. It's not going to be equal to 7. There's no way it's going to be equal to anything. So this is totally not an answer. So what do you put as the real answer to that problem?
X 0 is 0.
This has no solution at all. If you showed this as a graph and you graphed that and saw where it crossed 7, it would not ever cross 7. There's no way to make it happen. We'll see that next week. On this one, if you just quickly check, you can plug it in and of course check it real carefully, but if you just look at the bottom at least, that's all I expect you guys to do. Look at the bottom. Is it going to work probably? Yeah, I mean, it's not going to at least break the bottom, so you can just assume it works at that point. That way you don't have to check your answers fully. Does that make sense? So just real quickly do that on these. You'll be fine. Now there's other ways to solve these problems. The book might show you a different way, but this is the fast way. So let's start with this. All you need to know is factoring, that's it. Okay?